So we're going to make a start on transformations of graphs. So here is the idea, okay? The idea is if we can understand a basic graph, okay, so if we can understand like a parabola, or if we can understand a straight line graph or a cubic graph, then from that we're able to establish what changes we can make to make the graph look different. That's the basic idea, okay? So I just want to get some notation kind of nailed. I want you to understand some notation before we make a start on this. So it's this idea of a function. Now, a function is a very, very simple but very powerful idea in mathematics. And it's simply a way of connecting input values with output values. Okay, so the idea is of a function. You put a value in, it's input, and therefore you get a value out, so it's an output, okay? Now just by notation, just by convention, the value that we put in, we usually give the letter x. It doesn't have to be x, it can be any other letter you like, okay? But just by convention, we usually say that our inputs are called x, okay? And therefore, because you put a value of x in, the output has to come after you put the input in, therefore we give the letter y to represent the output, okay? So let's say, for example, the function, the thing which is happening in the middle, it's a nice simple rule, it's just simply times by 2, then add 1. Okay, so times it by 2, then add 1. So if I put, I'm just going to give you a few inputs to have a go with. If I put 3 in, what's my output going to be? Not 6. And my function, my rule, times it by 2, then add 1. 7, perfect. If I put 10 in, what's my output going to be? 21, perfect. If I put negative 4 in, what's my output?
Negative 7.
Perfect, well done. Okay, so the idea is, it's just a way of connecting inputs with outputs, okay? Now, just because I want to put some notation on here, in this case, if I put x in, so if I just say my letter x, if I put a letter x in, what's my output going to be? How would I write my output?
2x plus 1.
Perfect, 2x plus 1. So therefore, I can say that in this case, my function, so my output y, if my input is x, then my output will be 2x plus 1. My input is x, my output will be 2x plus 1. Does that make sense? Yeah? So just simply a way of writing inputs and outputs. Now just because I know that my output y is given by taking my input, timesing it by 2 and adding 1, just because I don't want to write this out all the time, I'm going to use a bit of notation here. Instead of writing function, instead of writing my function is times it by 2 and add 1, my notation would say I take my input, which is x, and I apply a function to it. So I apply a function to it. So I'm just going to give my name of my function, I'm going to call it f, okay? So the way which I'd write this is f of x would give me my output y, okay? So my input, I take my input, apply it through my function, and it gets my output y, okay? And in this case, my output is given by 2x plus 1, okay? So I just really want you to understand this idea of function. It's a way of connecting inputs with corresponding outputs. Does that make sense? Yeah? So if I write that my function looks like this. Let's have a look. So let's suppose I have a function of x. So my output y is a function of my input x. And let's just suppose that my function x is given by x squared. Now all this is literally saying, take my input and square it. That's how I get my output. So my output is given by my function when I put x in, and in this case my function is just simply take my input and square it. Okay? What does this graph look like?
It looks like 1 on the left, sorry, right.
Yeah?
This will be the double
Yeah?
up.
Okay, so, well, okay, in this case, not quite. I think you're thinking of linear graphs. really annoying. I think you're thinking of linear graphs. If I had something like y equals 2x, that would be a linear graph where the gradient is 1. Okay. In this case, the x squared graph, it's a parabola. It would look like this. That's the graph y equals x squared. Does that make sense? Yeah, so it's no longer a linear graph, it's a parabola instead. All right, good, fantastic. Okay, so what I'm going to do then, is I'm going to actually physically plot this by looking at some input values and their corresponding outputs on a table. Okay, so let me ask you this. If I put 0 into my function, which in this case is x squared, what's my output going to be? 0, good. So in this case, my function, f of x, is equal to x squared. Okay. So yeah, if I put 0 in, I get 0 out. What happens if I put 1 in? What value do I get out? Good. If I put 2 in, what value do I get out? Good. And if I put 3 in? Good. Let's do the negatives then. What happens if I put negative 1 into my function? You sure? Good, because negative 1 squared is just 1. Perfect, well done. Put negative 2 in. Good. And negative 3. Good. Excellent, well done. So this is basically a set of inputs and a set of corresponding outputs for y equals x squared, f of x equals x squared. So therefore, if I'm going to draw this graph, it would look something a bit like this. Okay, so it would be my basic parabola. It's not a brilliant graph, but it's basically following this shape. Okay. Now what I want to do is I want to transform this because sure, okay, I've got my basic parabola, my basic kind of U-shaped graph, but what happens if I want to shift it around a little bit, or maybe move it up and down, or left and right, or stretch it around, or maybe reflect it? I want to basically see how I could do that from an algebraic point of view. So let's consider this. Let's consider f of x plus 2. Okay, so f of x plus 2. So in this case, what I'm literally saying is my f of x is just x squared, and then add 2 to that. Okay. So let's see what happens. If I stick 0 into this thing, what do I get out?
2.
Good. If I stick 1 into this thing, what do I get out?
2.
Sure.
Yeah.
So 1 squared
1.
plus 2. 1 plus 2.
3.
3 years, well done. You're tired, that's fine. If you stick 2 in here, what do you get out?
6.
6. And if I stick 3 in?
11.
Good. Now, what happens if I stick negative 1 in there? 3. And if I stick negative 2 in? And negative 3?
11.
Good. So you see this kind of symmetry happening. So at the moment, the symmetry is happening around 0 with both of these cases. Okay. So as soon as you hit 0, the graph is going to be the same on either side of that, whether it's positive or negative. But let's draw it. Okay. So I've basically got a graph that looks something a bit like this. Okay. Now, I wonder if you can tell me what has happened to this graph. So this is our basic y equals x squared graph. As soon as I take x squared and add 2 to it, what's happened? What have I done to get from here? How would you describe it?
That one touched 0 and this one doesn't.
Good, so you're looking at the vertex. So that vertex there, the vertex there for this one is 0, 0, whereas the vertex for this one is
0 and 1.
0 and
2.
2. Good, well done. But how would you physically describe it? What have I done to get from this graph to this graph? What's happened? So sure, the vertex has changed.
X is different.
The x is different.
F of x.
F of x is different. Okay, how is it different?
We add 2.
Okay, so remember f of x, good. So f of x, remember, is talking about your outputs. It's how you get your outputs from your inputs. So what you've done here is you've changed your output value, haven't you? By moving it upwards by 2. So the way which I can physically describe this to get from this graph to this graph is I have taken this graph and let's just pushed it up by 2. Does that make sense? Okay. So I would call that either a shift is fine, or a better word for it is a translation. Now, how many units have I moved? 2 units. So a shift or translation by 2 units. Which direction? That direction or the x direction? X direction or y direction? Y direction. Okay, so shift or translation by 2 units in the y direction. What that's literally saying is you take this graph and shift it up by 2. Can you see where that 2 is buried within our function notation? Yeah, exactly. So basically I'm just adding 2 to my function, okay, in that case, and that should correspond to a shift or a translation by 2 units in the y direction. So in other words, if you know what your original function is, whatever that original function is, I've just used x squared. It could be x cubed, it could be 3x, it could even be something funky like e to the power of x, or 2 to the power of x, or log of x, okay? If I add 2 to that function, it will always, always, always correspond to a shift or a translation by 2 units in the y direction, okay?